this whole unit is about. So what we're going to start to do is look at quadratic equations and actually start solving them. I forgot about this page right here. So a linear function forms. We're going to fill in the blank. What type of graph do you get when you graph a linear function? Yeah. What do you get?
Straight line.
You get a straight line. So a linear function forms a line. You can put a straight line just to make sure that you know that it's a straight line. So if you have a linear function when you graph it, you're going to guarantee get a straight line. It's always going to have one x-intercept, and it's always going to have one y-intercept. It's a guarantee. That means if you have a linear equation, you're going to be able to solve for the x and the y-intercept by hand. Who remembers if you're looking for, we're just going to find the x-intercepts. We're going to talk about the y-intercepts. If you want to find an x-intercept algebraically, what do you have to do? Yeah. Make y equal to 0. That's a good thing to know. Every time that you're looking for an x-intercept, y always equals 0. So if you were to have this equation right here, and you want to find the x-intercept, then you make y equal to 0. And you have that new little equation set up for you. You then have to get x by itself. So you're going to add 1 to both sides, divide both sides by 4. So 1 over 4 would be equal to x. That's where your x-intercept is. It's at 1 divided by 4. If you want to find your y-intercept, you would make x equal to 0. Right? We're not going to actually write that out. We're just going to talk about it. But if you want to find your x-intercept, y equals 0. That's going to be an important thing for us to recognize and understand. Linear functions always have something called a slope. And that slope can be found using this formula that they have right there. So if you have the coordinates of 2 points on a graph, you find the slope by using this formula. That should be from Math MC, straight out of there. So you take 1 point, you call it point 2. You take another point, you call it point 1. The y value at point 2 and the x value at point 2 go there and there. The y and the x values for point 1 go there and there. We're not going to do a lot with slope. 1.2 here says if you have an equation, rearrange it in the form y equals mx plus b. Anybody heard of that before? Yeah? Where m is your slope and b is your y-intercept. So anytime you have a linear relation, if you can get y all by itself, you can find the slope and the y-intercept really easy. They just stick out to you. Simple. We're not going to find out. So, functions. You guys should have learned all about functions and equations and the difference between functions and equations. A function is a function when it passes the vertical line test. So it's just like how it is. A function is a function. We should say an equation is a function. That's okay. It passes the vertical line test. Remember, that's when you would take a graph and you try to draw vertical lines through it, and if it touched it more than once, then it wasn't a function. If it never touched it more than once, then it was a function. We're going to spend very little time actually doing this. It's just kind of a review of what functions and equations are. That's all we're really doing. Or it does not repeat any x values. Linear equations are linear functions if they have both an x and a y variable, or if it has only a y value. So anytime you see an equation, if it looks like the ones we were just looking at, With these ones, it has an x variable, has a y variable. This thing's linear. I know right away it's got to be linear. There's no x squares or there's no z's. There's nothing crazy in there. There's just an x and a y. Boom, it's simple. Anytime you have two variables, you're good. It also works out if there's just a y variable. So if it's at like y equals 2, that would still count as a function, a linear function. Y variable equations, looking at y equals 2, for instance, form a horizontal line. Which would pass the vertical line test, but we're just going to put VLT for short. It's a much quicker way of stating vertical line test. Lines with both variables are just called diagonal lines, right? You've seen them a million times. They just cross down and all they're diagonal. That's not VLT. Again, this is all just kind of review about what vertical lines, what straight lines look like, and what straight line functions look like. So, we have some data here. They want to ask, is this a function? To tell us something's a function, we're going to graph all those points. So 3, 6 is up here. 4, 6 is up there. 5, 5 is right there. 6, 2 is right there. 7, 1, we're going to have to move over a little bit. So I've just plotted all those points. I'm just looking where they are. If you want something to be a function, then it does not repeat any x values. Did we repeat any x values here? No, we didn't. So would this thing be a function? Yes. The answer is yes. It is a function. Now you should hopefully remember something called function notation. Right? So then after you learned what functions were, you learned about something called function notation, where instead of saying y equals something, they would say f of x equals something. F of x looks like this. Anytime you see that, it's telling you that the thing is a function. So if you see a question that says f of x equals something, it's saying this thing is a function. It has to be. If you see y equals something, then it doesn't mean it's a function. It could be a function or it could not be a function. We're not sure. That's where function notation comes from. You guys might have taken another class where they talk about storing values in your calculator. I don't store values in calculator. I don't teach how to store things in a calculator. So if you know how to do that and you're really good at it, cool, feel free to keep using it. But you're never going to hear me talk about it. I find that people just make mistakes when they try to store values. So I just rather teach you by hand how to do it properly. So, example 1 says write the equation y equals x squared minus 1 in function notation. The only thing that's different is that instead of y, they have f of x. So to change this to be function notation, it just looks like that. Example 2. Find f of 3 if f of x equals this thing. Alright, you're going to see this kind of stuff throughout the semester. This is where function notation is useful. Because now they can write questions like this. They'll say, find f of 3 if f of x equals something. What's the difference between this f of 3 and f of x? Yeah, the 3 is x. So what they're telling you when they write something like this, they're saying x equals 3. So if you go back into your question, they're saying change x to be 3 everywhere you see it. So instead of f of x, we have f of 3. And anywhere we see an x, we're putting a 3. You notice that when I put a 3, I'm going to put brackets around it. those brackets are important. They're especially important when f of x is like f of negative 1 or something like that. Because those brackets mean that negative stayed with it. Okay? So make sure you use brackets when you substitute things in. At this point, all you have to do is calculate it. So f of 3 equals 3 cubed is 27. 27 times 4 is 108, plus 1 is 109. So 109 divided by 6. That's what f of 3 would be equal to. So the function at value x equals 3 equals 109 divided by 6. That's what that's saying to you. When x equals 6, y is equal to 109 divided by 6. All right. That's all lines, linear, that's all review. Everything we just did should have been straight out of Math 10C. It would have been right at the end of Math 10C. We're going to talk a little bit more about functions when it comes to quadratics, but then we're going to talk about quadratics, and that's the difference between 10C and 20-1. Is 20-1 works with something called a quadratic. So a quadratic equation is something that can be written in this form, which you guys have definitely seen before. So ax squared plus bx plus c equals 0. That's called quadratic equation. That's the form that's in. Where a, b, and c are constants, and a cannot equal 0. So that means these numbers are all just solid numbers. They're not variables. So that it could be anything you really want. It could be fractions, could be decimals, could be anything. The only restriction is that a can't equal 0. That's the only restriction. We look down here. Which of the following are quadratic equations? So if we look at a, is this thing in that form? Yeah. Most people look at this, they look at that, and they go, no, it's not in that form. But it actually is in that form. And here's how I'm going to write it out so you see that it's in that form. We have x squared plus 0x's minus 9. Do you see now how this is actually in that form? But why would I write 0x? What's 0 times x going to be? 0. So I don't need to write that. So they didn't write that. But this actually is a quadratic equation. This is in that form. It's just the b value is equal to 0. No.
How do you know that? How do you know they don't want to write x squared minus 9?
That is what they would write. This is a quadratic equation because the b value is 0. But why would we ever write the b value as 0, right? Because 0 times anything is going to be 0. And if you're adding 0 to something, it's still whatever that was, yeah. So they don't write it in there. But I'm writing it in there just to show you that this is a quadratic. Yes?
So in other words, just a gray value, if it's anything but 0, it's a quadratic.
Pretty much. We're going to get there. It's coming. We're going to have some situations. We're going to talk about it. And if I don't cover your situation, then you can ask. So if you look at B, is that thing a quadratic equation? Right now, it doesn't really look like it because it's not in that form, but it actually is a quadratic equation. Their C value is just in a different spot than our C value. So for instance, if I subtracted 10 from this side, I would have 2x squared minus 3x minus 10 equals 0. So this was a quadratic equation, it just wasn't in our general form that we are talking about. If we look at C, is this thing a quadratic equation?
No.
Why is it not?
There's no x squared.
Because there's no x squared. And the reason there's no x squared is because a was equal to 0, which is not allowed. So this brings up what Kayla said step. Basically, you're going to look at questions, and you're going to check to see if there's an x squared value. If there's an x squared value, it's probably a quadratic. So this thing would not be, because it doesn't have an x squared. If you look at D, D does have an x squared, but what else does D have? It has an x cubed. Does our form have an x cubed? No. So this is also not a quadratic because it has an x cubed. So that brings a second rule to us. The highest exponent that we can have is x squared. Anything higher than that means that we don't have a quadratic anymore. This thing would be called a cubic function. Yeah.
I'm assuming we're getting to this, but don't I recall like a hierarchy number you call it simplified down to a quadratic?
I'm not sure what you're talking about.
Yeah. It's not.
Okay. Basic rules. You're going to look at your quadratic. You're going to look for an x squared. If it's got an x squared, it's probably a quadratic. If you have like an x to the negative 2 or something, obviously it's not a quadratic. The only other x that you're allowed to have is something like this, where there's only an exponent of 1 on it. Any questions? Any situations where people are like, would that be a quadratic? It usually covers most of the bases. Okay. To solve a quadratic equation, which is what we're going to do. That's what today's all about. An equation with two binomial factors, we need to use the zero product property. You're going to hear me use that term a lot. That's why it's bolded. That's why it's black. So it's a different color on your colored paper. The zero product property is just a basic rule that we already were just talking about. And the zero product property means anything times 0 is equal to 0. You've known that for a long time. The idea of understanding that 0 times anything equals 0 is called the zero product property. And we're going to use that to solve quadratic equations. If you ever read this and you're like, zero product property, that confuses me, and you're not sure what it is, my suggestion in math is to always try to break down words. Y'all know what the word zero means. It means zero. What's the word product mean in math? It means multiply. So this is the zero multiply property. And maybe that'll help you remember, oh yeah, anything times 0 is 0. So it might be able to help you if you ever like, what's zero product property again? Here's a question. We're going to talk about it. It says if we have a binomial times a binomial equals 0, then I can solve this thing for x. I can figure out what x equals based on the zero product property. Because what's the only way I can get two things multiplied to equal 0? Well, one of these has to be 0. I don't know which one. But one of them has to be 0, because that's the only way you can get something equal to 0 using multiplication. So if I'm trying to figure out what x is, and I have x plus a as this binomial, then x has to be the opposite of whatever that was. So x has to equal negative a. And that's this part right here. X equals negative a. That would make this thing equal to 0. What would make the second binomial equal to 0? If x equaled negative b. So this question would have two solutions. It would have x equals negative a and negative b. Check your answers. You substitute them back. Okay, so if you want to see, did that actually work? Well, change x to equal negative a. Negative a plus a, negative a plus b equals 0. What's negative a plus a going to equal? 0. Negative a plus b, can I combine those? No. What's 0 times anything? 0. I don't care what this binomial turns out to be. I don't care if a is a million. It does make a difference. Because anything times 0 is going to be 0. So in this case, 0 equals 0. That means we did it properly. So you can check your answers by taking your answer and putting it back into the question. You could do the same thing for negative b. And it would work. All right, let's try with numbers, because that sometimes helps. We got 2 questions. We're going to do the first one right now. So I have x plus 2 times x plus 5 equals 0. The only way I can get something to equal 0 is if it's 0 times something. So I need to somehow change these things so that they would end up equaling 0. What value of x would make this first thing equal 0? Negative 2. Right? Negative 2 plus 2 would equal 0. You always want this to be the opposite of that thing. So if x equals negative 2, that's one answer. Because negative 2 plus 2 is 0. 0 times anything is 0. What would make this second binomial 0? Negative 5. The opposite of what's in here. So x equals negative 5. Those would be your 2 answers. If you don't believe it, if you're not sure, then check it. Put those numbers in and test it. Alright, that's an easy scenario. That one's easy. You'll notice that these ones are a little hard. Because you'll look at these, and what people seem to do is they think, well, it's just the opposite of whatever's by itself. But that's not going to work here, because x isn't by itself anymore. So for instance, if I put negative 1 in here, negative 1 times 2 would be negative 2. Negative 2 plus 1 is not 0. So that's not going to work. So what I do is I take this thing inside the brackets, this 2x plus 1. What do I want it to be equal to? 0. So I say 2x plus 1 equals 0. And I'm going to solve that thing for x. And that's going to tell me what x would be. So I'm going to subtract 1 from both sides. So I have 2x equals negative 1. I'm going to divide both sides by 2. So that x equals negative 1. That's going to be my first answer from my first binomial.
Why is that negative 1 there underneath the 2x?
Because I had to subtract 1 to the other side.
So why is it still 0? Okay, never mind. Okay.
0 minus 1 is minus 1. Yeah.
Would it not work if you just divide it and put the right
Yep, so then you had x plus a half equals 0, and then just move the 1/2 over. Yeah, that'd work good. Okay, we're going to try it again for the second binomial, because this is just our answer from the first binomial. If I want to solve this second binomial, I'm going to do it in red. 5 is not going to work, because there's a number in front of that x. So what I do is I set it up on the side, and I say, I know I want that thing to equal 0, because that's the only way that this question could work. And then I solve that thing. So I'm going to add 5 to both sides. So 3x equals 5. And then I'm going to divide both sides by 3. So x equals 5 over 3. That's my second answer. Both answers are correct. Both answers work. Both answers you'll need on a test. Any questions about where those are coming from? All right. Now, we're going to step it up a little bit. So we're going to start solving some quadratic equations. If you look at that first question, it says x squared plus x minus 56 equals 0. I have no idea what x is. Pretty good math guy, no idea what x is. Right? If I put 56 in here, I know that's not going to work because 56 squared is going to be a huge number, and then I'm going to add 56, and that's just not going to work out for me. So, anybody have any ideas of how I could solve this thing? Let them. Yeah, I want to factor it. Why would I want to factor this? Someone other than Leto, give it a stab. Kills. It is a trinomial, yeah, and that's key because that means it could be factored, right? Dylan? There we go. What is factoring doing? It's unmultiplying. It's turning a question back into a multiplication question. And when we have multiplication, we can figure out what x must be equals 0. So we always want to change questions into multiplication questions, which means we're always going to be factoring. Now you understand why spending 3 days on factoring is probably pretty important. Because factoring is going to be the first step to every question we do. So we have this trinomial, this quadratic. It's equal to 0, which we always have to be equal to 0. We need to factor it. To factor it, we set up our diamond. Negative 56 goes on the top, positive 1 goes on the bottom. What would multiply to be 56, negative 56, and add to be 1? 8, negative 7. That means this thing factors to become x plus 8, x minus 7. And it's still equal to 0. See how I'm going to keep this all organized? It's always equal to 0 all the way. That's important. If your question started with an equal sign, it should have an equal sign all the way through it. The whole question needs to have an equal sign. Yes?
Isn't this something about when you put them in brackets now and go to the opposite sideline?
You're confusing a trick for solving these things. Yeah. Alright. I factored this thing, looks perfect. Now I have multiplication equals 0. Now I can use my zero product property. The only way multiplication can equal 0 is if these things individually equal 0. What value would make this first set of brackets equal to 0? Negative 8 would make that thing equal to 0. Negative 8 plus 8 would be 0. What value would make this second set of brackets equal to 0? Positive 7. And 7 minus 7 would be 0. 0 times anything would be 0. Those are your answers. Negative 8 and 7. Notice how I wrote them. You know, see how the page before I was writing them separately? Kind of a waste of space, right? So you write them out like this. You say x equals negative 8, comma 7. You kind of put them together.
So you have to have both answers.
Both answers need to be there. Yeah. Alright, let's try B. You look at question B and you're like, I don't know what value of x would work in there. I have no idea. So when we want to solve these things, we want to look at them and go, is that a quadratic?
Yes.
It is a quadratic. Is it in our general form that we're used to seeing, though?
No.
No. Remember, we always want things to equal 0. So we're going to add 20x to both sides. We're going to put everything on the same side. So 5x squared plus 20x equals 0. You always, always, always want to be equal to 0. You want to be in that general form. Now that you're here, you have a quadratic, and it's equal to 0. The only way we can figure out what's equal to 0 is if we... So, we've got a quadratic here. We've made it equal to 0. That was our goal. If we want to solve something equal to 0, we need it to be a multiplication question. So what do we need to do to this thing? Factor it. You've got to factor it. Factoring is what turns things into multiplication questions. What's the first type of factor I always got to check for? Can I GCF that thing?
Yeah.
What can I take out? And When I take out a 5x, I'm left with this. Now, first things first, as we go through this. Most people will screw up factoring method because they'll forget to just do a GCF. That's the easiest thing with factoring that you can do. So, make sure you're always checking for your GCF. I've harped on that about 1,000 times. Second thing, when you look at this question, it is a multiplication question. It's not a binomial times a binomial, but it is a multiplication question. And this is your first term being multiplied, and this is your second term. So there's two spots you need to check for answers. Most people only get the one in the brackets. What does x have to be to make this thing in the brackets equal to 0? So a lot of people get x equal to -4. A lot of people get that. What a lot of people don't get is that this x right here also is affecting things, because it's also multiplying. So what value of x go right here that would multiply by this binomial to make it equal to 0? Back? It's 0. If I put 0 in here, what's 0 times 5? What's 0 times anything? So 0 is the second answer in that question. And I promise you, you'll see a question like that on a test, multiple tests. And I promise you people will forget GCF. And I promise you people will forget about this guy out front. It makes a difference. Okay? There's two answers here because there's two x values being multiplied together. Yeah, Caleb.
Okay, so if it's a quadratic, why do we do like 0 plus 0x? You know how we...
Why didn't I write
Plus.
5x squared plus 20x plus 0?
Yeah.
Because I was just like, when I did that way back here, like that was a long time ago, right here, I only wrote it like that to show you that there actually is a 0 value there. That's all it was. We would never write that up. Right? That's just silly to write up. Because what's 0 times x? Exactly. So we came back forward into this question, and I add a plus 0 here. Is anything plus 0 going to be the same thing? So we don't write it out. Yeah. I only did that to make a point of this is a quadratic. It's just a sneaky quadratic. All right, last one right here. That thing is already in binomials. That's fantastic for us, right? We're like, hey, it's already binomials. We can solve this thing. Why is that actually not good for us right now? Front of it. Has to equal 0. Right now it equals 3. So that's not good for us. So if we want to solve this thing, it has to be a quadratic that's in that general form. That ax squared plus bx plus c equals 0. So how could I change this thing so that it would then have an x squared term in it, Kate?
Foil first, then bring the
Bingo. So I'm going to have to actually distribute these together, multiply them together, then move the 3 over so it can join all that stuff, and then I'll be able to solve that. But you can't solve it unless it's equal to 0. So what we're going to do is we're going to FOIL this. Okay? You should get 2x squared plus 2x minus 3x is minus x minus 3 equals. So if you need to FOIL that or area diagram that on the side, that's fine. All I did was I multiplied these two binomials together really quickly. Now I need to equal 0, so I need to subtract 3 from both sides. So now I have 2x minus x, 2x squared minus x, minus 6 equals 0. Now this thing's set up in a way that I want it set up. I have my general form quadratic. It's equal to 0. That's good news for us. We can solve that. What do we have to do to solve that? We got to factor it. So we're going to factor this thing. We're going to set up our diamond. On the top we have -12. On the bottom we have -1. On the sides we have -4 and 3. We set up our brackets. We have 2x minus 4. We have 2x plus 3. Remember, I started with an equal sign. Notice I've had an equal sign on every single step. This isn't completely factored. What do I gotta do?
Divide 1 by 2.
Divide 1 by 2. This one divides by 2 nicely. I have a multiplication question equal to 0. Perfect. I'm going to use my zero product property to solve this. What would make that first binomial equal to 0? X equals positive 2. Positive 2 would work because 2 minus 2 would be 0. 0 times anything would be 0. What would make the second binomial equal to 0, Jared?
You have to divide the 2 by 2.
Yeah, so this thing can be hard to notice what would work. So what we do is we write it out on the side. So right over here is 3. I go 2x plus 3 equals 0, and I'm going to get x all by itself. I know I want this to be equal to 0 because 0 times anything is 0. I subtract 3 from both sides. I have 2x equals negative 3. I divide both sides by 2. And I get x equals negative 3 over 2. So that's
Could you write
my second answer. You could write negative 1.5. On your test, it might be either. Because 1.5 is a pretty nice number, so they might actually do that. But if your answer is like 1.66666, like they're going to leave it as a fraction.
Could you divide the first bracket by 2 because of GCF or just?
Not because of GCF, because when I'm factoring, I can't have two 2's. Okay? Remember I put 2x and 2x because I know I needed a 2x, but I didn't want two 2's, so I figured which one of these could divide by 2. This one could divide by 2. That's solving quadratics. It doesn't get much more challenging than that. If you can recognize how to turn it into the form you want, if you're really good at factoring, and if you understand the zero product property, you're good to go. The biggest thing that hinders people is their factoring skills. That's why we did so much factoring to start this unit. Alright, we're going to stop here.